We're solving an equation with some radicals in it. When we're solving, we do always want to try to start with the order of operations backwards since we're undoing what was done. And the thing for this new section is that radicals and exponents undo each other. So if you have a third root, use a third power. If you have a fifth power, use a fifth root. They're just opposites. When I look at this particular equation, everything that's underneath this radical is kind of considered to be in the parentheses, a grouping symbol. So I'm going to look outside of there, and I'm going to decide if there's anything to add or subtract, and then I'll look to see if there's anything outside of these radical to multiply or divide. I'll treat the radical as kind of on par with an exponent, so I'll find the way to get rid of that, and then I start the whole process all over again with what's revealed once the radical's gone. So with that in mind, these are the two sides of my equation. I'm looking outside of the radical to anything outside. If there is something to add or subtract, I will start by subtracting 4 from both sides. These will cancel. The left side is left with a square root of u plus 6, and the right side is whatever 9 minus 4 equals, which is 5. I will look outside of the radical to see if there's anything to multiply or divide. There is not. I'm going to look outside to see if there's exponents, and basically exponents and radicals are on the same level. So I'm going to consider this square root the same way I would consider an exponent. If there were a little number in this radical, that index, I would take that power. But if there's nothing there, the default value, of course, is 2. So I will take both sides to the second power. On the left side, the square and the square root, they cancel each other out and leave just the u plus 6. And then on the right side, whatever 5 squared is, that's what we're going to put. 5 times 5 is 25. And now we start the whole process all over again. We're trying to get this u by itself. I'm seeing if there's anything to add or subtract. I see a 6 that's added. I'll subtract it. So my final answer is u equals 19. And now with these types of problems, you have to check them, because even if I do all my math correctly, I might have things that don't actually make the solution true. So I'm going to take this 19 into this original expression and plug it in, and I'm going to see if I get 9. If I don't get 9, then there's actually no solution. If I do get 9, then this is correct. So I've got to consider what 4 plus the square root of u plus 19 is. I'm sorry, that's not what I want to say. 4 plus the square root of 19 plus 6. And now we're not solving, we're actually just evaluating. So I'm going to do the regular old order of operations. I consider this kind of to be like a parenthesis or a grouping symbol. So I got to figure out 19 plus 6. So this will turn into 4 plus 19 plus 6 makes 25. Of course, the square root symbol is still there. I'll take care of this exponent-y, square rooty thing next. Square root of 25 is 5. I'll get 4 plus 5. 4 plus 5 makes 9. That's what I wanted to get. That's what I did get. My final answer is u equals 19. Verified. Good luck.